So I have a normal model, and my mean is 73.46. So I have an n 73.46, comma, it says my standard deviation is 3.33. Right. So I'm not going to bother figuring out the numbers right now, but I can calculate all of my standard deviations properly without just a little bit of addition and subtraction. Everybody knows how to do that, right? Everybody does that pretty well. Okay. If the normal model is appropriate, what percent of the times should be within 1.67 seconds of 73.46? So that's telling me that they want to know, I want to go within 1.67 seconds, so I want to go 1.67 seconds that way, and I want to go 1.67 seconds that way. Questions as to why I'm thinking that? Because if I was, if I don't know where it falls on the model here, but if I was here, I would be within 1.67 seconds of my mean, and same thing over on that side, right? All right, so what are those values? Can somebody take 73.46 and add 1.67? What do I get?
75.13.
75.13. And what would I get on the other side here? 71.79. All right, does that make sense to everybody? I question. We're totally okay with that. Those are within 1.67 seconds of either side of the mean. Okay. So what is the z-score for the 71.79? Negative 0.5. And how did you calculate that?
I did 71 points. Well, I just did, yeah, 71.79 minus 73.546 divided by 3.3.
Divided by 3.3. Okay? I had my z equals y minus y bar over s, right? Our trusty formula. So there's our y, because we just calculated it. There's our mean, our y bar. There's our standard deviation. It gives us a z-score of negative 0.5. Everybody okay with that? Yeah? Okay. And I'm going to go way out on a limb and say that our z-score for this one here is going to be positive 0.5. You can calculate it, but I will go so far as to guarantee it. Right? Because if I'm going 1.67 that way, and it's taking me half a standard deviation, if I go 1.67 that way, it's going to take me half a standard deviation. So is everybody okay with that? Okay. A number of people have been coming in over the last couple of days to kind of go over this normal model stuff, and what I'm trying to, one of the things I've kind of gotten across maybe sometimes is we have two functions on our calculator that we can use to solve these problems. In fact, let's flip the screen for this, just so that we can look at it better. Okay. We have normal CDF, and that takes a z on the left and a z on the right. So for the normal CDF, what I'm finding out is I'm going from z-scores to percentage. That's what normal CDF gives me. And the other one I have is inverse normal. And that takes one argument, which is a percentage. And that's when I want to go from a percentile to a z-score. So if you remember those two things, that'll help you figure out what is it that I need. And so what they're asking here in this question, number 22, says, what percent of the times should be within 1.67 seconds of the mean. Right? So they're telling you, give me a percent. Right? Well, I say, oh, well, if I want to wind up with a percent, I need to have two z-scores. I need to have a left z-score, and I need to have a right z-score. And if I have a left z-score and I have a right z-score, that's going to give me the percent under the curve. That's going to give me the percent of the data that they're asking for. Does that make sense?
Mhm.
Yeah. Okay, so let's draw it in here. It's a half this way and a half that way. So I want to know this area right in here. I want to know what percentage of all the data points that represents. Okay, so let's go back to, I want to use this function, right? So what's going to be, whoops, how do I get that? Okay, we're going to reduce that guy here. Okay, there we go. I want to get the percent, so I have a left z, don't I? And I have a right z, right? Second quit. Second bars, normal CDF. My left z is negative 0.5. And then I have a comma. And my right z is 0.5. Close my parentheses, hit enter. So what percentage of values should be between those two times? 38%. Right? Yes?
How come we didn't do normal CDF 0.5, 99, negative 9.5?
Okay, so say that again here.
So how come we didn't do normal CDF 0.5, 99? Oh, it's because it's in the middle rather
Yes.
than, okay.
Got it?
Yeah.
Right. Left z, right z.
Okay.
Right? If they were asking me what, think about this here, right? If they were asking me what percentage of the times should be above 75.13, right? Then I would have my left z here, and I'd have my right z across the street at 99.
Okay.
Does that make sense, everybody? Yeah? Okay. So they're telling me 38% of the time I should be between these two scores, right? Okay. They told me in the beginning of the problem that the top 25 men and the top 25 women's speed skating times are listed below. So I know that I have 50 times in this table, right? 25 plus 25. How many times in this table here are actually between 71.79 and 75.13? You can look at the table because they're in order, so count them, right? 71.79. I see on page 136, I go down to Eric Brisson of Canada, and he's 71.54, but the next person is 71.96, which is between those two numbers, right? Everybody with me there? And then the 74.75, the next one is also between those two numbers. And the 74.94 is still within those two numbers. And then I get a 75.19, which is off the out of the range there, right? There's only three numbers that are within these two times, right? You agree with me there? Right? There's 50 total participants. There's only three times that are falling within there. That is 6%. Right? 3 out of 50 is 6%. Okay? So I have actual is 6%, but my model says it should be 38%. What gives?
Wait, how do you find the actual 6%?
I found the actual 6%. I know that there are 50 times.
Oh, so it's just 50?
Yes, I divided 3 by 50, and that should come out to 6%.
Okay.
Right. Yes.
Can you go back to the next page of notes?
Yes. Right there. Okay. So I'm asking the question. There's only 6%. If the normal model says there should be 38%, why? What's the deal? What happened here? Why isn't it working out?
Doesn't fit a normal model.
Who said that? Yeah, doesn't fit a normal model, right? And this is where you know, if you added all the data in here and you put it into your calculator, just think about it for a minute. What kind of a histogram would show up? This is data. Jackie, go ahead.
If it was the normal model?
It isn't the normal model, though. So I want to know in this actual data, what kind of histogram is going to show up? I have the 25 top men and the 25 top women. What kind of a histogram is going to show up? Yeah, Valeria.
Oh, bimodal.
It's going to be bimodal, right? Because the men and the women's times are going to be different, right? Well, I got a bimodal distribution. I can't use a normal model for that. Boo, you know. So that's why it doesn't work. Right? Make sense? Right? So actually, we would have only had to enter in all the data if I wanted to show you that histogram, right? But otherwise, you actually could have done this problem without even having to enter in all the data. Good with that? Yeah? Okay. That's another really good problem. You know, a lot of different aspects to it. You know, kind of a little bit challenging, not too overwhelming.
Slow down.
I will, just